Kia ora. This is a great little flash simulation to explore solubility product and how it relates to solubility. So we've got different salts here that are all sparingly soluble. So the first thing you need to look is it an AB salt, an AB2 salt, or an A2B salt? And we are given the solubility products constants on this side. Now remember, you can only compare the values if it's the same type of salt. So let's look at silver bromide. Initially, we have silver bromide solid and none of it has dissolved. So I have 0 silver ions or bromide ions. But if I react it, then some of the silver bromide dissolves to form silver ions and bromide ions until it reaches an equilibrium where the concentration is constant. But remember, the reaction is not constant in that I still have dissolution happening and deposition happening. In other words, my forward reaction rate is the same as my back reaction rate. Now, if I choose calcium carbonate, which is also an AB salt, I can compare my Ks values. This is 3.3 times 10 to the minus 13, whereas my calcium carbonate is 3.8 times 10 to the minus 9. Which one is bigger, and therefore which one would be more soluble? Now, please note the error. That should have been a capital O for oxygen. So let's have a look with this one and see what happens if I react it. Notice 3.8 times 10 to the minus 9 is a bigger number, so calcium carbonate is more soluble, so more has dissolved than for the silver bromide. I recommend that you write the solubility product expression, do the calculation, substitute the Ks value. Do you work out the solubility to be the same as this? And you can do the reverse, use the solubility, and see if you get the same solubility product value that was given over here. Now let's look at an AB2 salt. So we can't compare this value directly with the one for silver bromide or calcium carbonate because these were AB salts. This is an AB2 salt. And so I can't say that lead chloride is more soluble than calcium carbonate. But you can see clearly that I have twice as much of chloride going into solution than as you've got for the lead 2 plus. Now remember, this is all solubility in pure water, so my only source of lead ions and chloride ions are coming from the lead chloride that I added. And I can do the same thing for this AB2 salt. You can think about it. Is my iron hydroxide more soluble or less soluble than lead chloride? Let's react, and it looks as though actually it's more soluble, but actually the scale has changed here. But you will see that I've got twice as much of hydroxide as the Fe2+. And then see what happens with an AB3 salt. But it's good if you did the calculations and just checked that you could do these without any issues. Kia ora.